Oh, look me all the way up here. I feel like I'm in the nosebleed section. Dang. Okay, so now I'm using the same equation as I was on part A, but this time I'm spinning about the y-axis. So my first question is, discs, washers, or shell? Well, if I'm spinning about the y-axis, my first thought is, why can't I use the washer method? I see that there's a gap. And so if I were using washers, I would have to draw perpendicular to my spin axis all the way over for big radius. And then I'd have to draw from my spin axis to the far right of the gap. So there's little r. And that doesn't look like a problem. I think I could do that. Except then I have to use, of course I'm using dy, and I would need to know the bounds for y. Well, the lowest bound on my shaded region would be 0, but the highest bound, that's a problem because this bound is not static, it's changing. So I don't know what number to use for that upper bound, and therefore I can't use washers. So the only other option I now have is I must use shells. Okay, so now I have to erase, and then we're going to do the shell method. Okay, so remember, with shells, my H is parallel to the spin axis, so I'm going to draw in some random height of a shell, and then my radius goes from the spin axis over to that height. So now, when I'm calculating what the value is for my radius, again, it's some length x on the right minus 0 on the left, and my height is top, well, that's my curve, 1 over x squared, minus the bottom, which is 0. Oh, I'm ready to integrate. Awesome! So I've set up my integration. I substituted in r and h. And since I'm about the y-axis, then I'm integrating with respect to x. Good thing, because everything has x's in it. And so now I have to find my bounds for x. So the leftmost value of the shaded region is 1, and the rightmost value is 4. Okay, so now you run ahead on that integration, and I'll catch up. Did I get it? Did I get it? Check my work. Ooh, this one is tricky. Now, I'm going to tell you that you could use the washer method, but I'm going to force you to use the shell method because this one is different. So, the first thing I notice is since I'm spinning about y equals 1, my height would of course be parallel to that. So it'll be parallel to the x-axis, which means I'm using dy, and therefore I'll need my equation in x equals. So the first thing I'm going to have to do is change this equation into x equals. Whoop, there it is. So now I'll draw in my height parallel to my x-axis, and then my radius has to connect from spin to height. So there's the radius, this of course is the height. And so now to find each of them, my radius is top, which is 1, minus bottom, but this bottom is going to be some y value. So that's going to be 1 minus y. And the height is right, but that's the curve, which is 1 over the square root of y, minus the left, which is 1. Now, here's what you need to notice. This is why this one's tricky. Because that height, eventually, if I draw it in, is going to actually get down to 4 minus 1, which is 3.